All right, so this is a slide from your reading material, and it basically breaks down matter into a couple different groups. The so-called pure substance here is meant to be a single chemical entity. Now this gets a little fuzzy and where I kind of differ from Averill, but it's meant to be a single elemental or molecular entity that is defined as an element or a molecule. Now, the molecule can pack to form a solid, and the solid is actually composed of millions of the same molecule, or billions or trillions of the same molecule. But it's so-called pure substance because it's an identifiable molecular entity. Then there's the other part of matter here that are essentially mixtures. So there are two types of mixtures, one in which that are completely homogeneous down to the molecular level. Those are we call solutions. So you mix two different things that are completely soluble in one another, you get a solution. The other type of mixture is what are heterogeneous, so that on a scale much larger than the molecular scale, you will see regions of different composition. So think concrete, right? It's got aggregate in it. It's got, some calcium silicates. It's got, complicated mixture at in that case, it's the millimeter centimeter scale. To your eye, it may look like a single material, but when you actually look at it under a microscope, you see the heterogeneity that's in it. Now, in many cases, while this is heterogeneous, the heterogeneity is determined by the chemistry. In other words, it may have started as a solution, and I do something to it, let's say cool it, and it phase separates. So just because it's heterogeneous doesn't mean that chemistry didn't tell you something about it. And so we're going to learn about that over the course of the semester also.